This problem shows a lovely picture of a rocket represented by my little rocket-esque looking object. And it tells us that the rocket shown in that picture is decelerated or slowing down at a rate of 196 meters per second squared. What force is necessary to produce this deceleration? Now we're going to assume the thrusters of the rocket are off. It is just decelerating due to the force that's being shown as friction. And we know that the mass of the system is 2,100 kilograms. So we are told that the deceleration is 196 meters per second squared. That tells us that the rate of change of the motion of this rocket is 196 meters per second squared. If it's slowing down and the rocket is moving to the right, that means the acceleration is to the left. So the acceleration of the object, since we know it is slowing down and the rocket is moving to the right, the acceleration is negative 196 meters per second squared. Okay, so it wants to know what net force is required to produce this deceleration. We know from Newton's second law that the net force is equal to the mass times the acceleration. All right, so the net force is what we want to know. The mass of the rocket is 2,100 kilograms. The acceleration is minus 196 meters per second squared, and that tells us that the force necessary to produce this acceleration or slowing down, which we also call deceleration, is negative 4.1 times 10 to the 5th newtons. All right, so recognizing that motion, that slowing down, since the object is moving to the right in my picture, that slowing down tells us the acceleration is negative. Moving to the right, slowing down, opposite directions, acceleration has to be negative. We can use Newton's second law to determine the force required to do that. What's causing that force? That friction that's drawn in the picture. All right, good job.